Welcome to Brain Vision.
So we should write down our givens. The volume of this sphere is going to be 0.650 meters cubed. And then we have the force tension of 1,120 newtons. So first we should assess the buoyant force on the cube. The buoyant force on the cube can be equal to the density of the water times the volume of the the sphere times gravity. Here, we simply substitute in for our density of water of 1,000 kilograms per meter cubed, the volume of the sphere being 0.650 meters cubed, and then gravity being, of course, 9.8 meters per second squared. We find that the buoyant force is equaling 6,370 newtons. At this point, they ask us, okay, what is the mass of this sphere? So essentially, when we have the sphere, we have a rope connected. So we have a sphere, and the buoyant force is pushing this up. And then, of course, we have force tension and force gravity. So when we solve for this in the y direction, this is not moving. So this is going to be 0. And we see that the buoyant force minus force tension minus force gravity equals 0. Or the buoyant force equals the force of tension plus the force of gravity. Now, we need to solve for gravity. We need to solve for the mass. So the force of gravity of the sphere can also be force tension plus mg. Once we have this, we can isolate m, and we can say that m equals the buoyant force minus the force tension all over the the acceleration due to gravity. Plugging in for our constants, we have 6,370 minus the force tension, which is given right here. That's going to be 1,120 newtons, all divided by 9.8. And we have the mass of the sphere is going to be 535.71 kilograms. So at this point, they're saying that the rope breaks and the sphere rises to the top. So given this, we now know that given that we don't have a rope anymore, we can say that the buoyant force, in order for the sphere to float, the buoyant force must equal the force due to gravity. Now, we want to find the percentage that is submerged. So we're going to further define the buoyant force as the density of water times the volume that is submerged times gravity. And this is going to equal the mass of the sphere times gravity. Gravity, of course, cancels out. And we have that the volume submerged is equaling the mass of the sphere divided by the density of the water. Plugging in for our constants, we have 535.71 kilograms divided by 1,000 kilograms per cubic meter. And this is going to approximately equal 0.536 meters cubed. The percent submerged is simply going to equal the volume submerged divided by the volume of the sphere times 100. and this is going to equal 0.536 divided by 0.650 times 100. And the percent submerged would be equal to 82.46%. So this is the answer for part C. Once the rope is cut and the sphere rises to the surface of the water, in order for this sphere to float, 82.46% of the sphere's volume must be submerged underneath the water in order for this to float. And that's the end of the solution. Thank you for watching.